SP9 forces and their effects. 9.1. Describe with examples how objects can interact at distance without contact, linking these to the gravitational, electrostatic and magnetic fields involved. So what you say is that the fields interact, so that's either the gravitational field, the electrostatic field, or the magnetic field. This causes attraction or repulsion, and the object moves toward or away from each other. So that would get you up to 3 marks. Electrostatic forces are basically like positive charges and negative charges. So if you've got 2 positive charges, they'll repel. If you've got opposites, so positive and negative, they'll attract. And if you've got, once again, 2 like charges, but this time they are both negative, they are going to repel. Magnetic fields. So just like the electrostatic fields, magnetic fields, if you've got a north and a south, opposites attract. If you've got like poles, north and north, they'll repel. And also if you've got 2 south poles, they're like poles, so they'll also repel. And gravitational field, well, obviously the thing is with gravity is they can only attract. Describe with examples how objects can interact by contact, including normal contact force and friction. So as well as having a non-contact force, we can obviously have a contact force. So normal contact force is the force pushing upwards as a reaction to perhaps weight pushing downwards, which ties in with Newton's third law. For every action there's an equal and opposite reaction. Other contact forces could be friction, which is a force that opposes motion. So this force over here is trying to make the object move that way, and friction is trying to stop it. Producing pairs of forces which can be represented as vectors. So remember, a vector is something that's got size and direction. So these arrows have got a size and they've got a direction. 9.2. Explain the difference between vector and scalar quantities using examples. So a vector has size and direction, whereas a scalar has size only. Some examples of scalars are speed, mass, energy, distance. Some examples of vectors are velocity, acceleration, weight and displacement. The most common ones is if you give speed a direction, it becomes velocity, and if you give distance a direction, it becomes displacement. 9.3. Higher only. Use vector diagrams to illustrate resolution of forces, a net force and equilibrium situations using scale drawings only. So in other words, if you've got one vector with the size and direction, let's call it A, and then another vector B. If you add A to B, you'll end up with C, which is the resultant. Now let's see how that gets applied with scale drawings. So just say you've got this object here, and the examiner tells you there's 10 newtons of force up and there's 40 newtons of force down. With a scale of 1 centimetre for 10 newtons, what you need to do is draw a parallelogram of forces, or we use the tip-to-tail addition of vectors. So in other words, if you picked this vector up and take and add that tail to this tip, so pick that up and pop it there, draw it there, and also if you picked this vector up and draw it onto the end of this vector, what you'll end up with is this vector here, which is the resultant. Now all you need to do is measure it with a ruler, and every 1 centimetre would be 10 newtons for this particular scale. Now sometimes they can give you the resultant and they ask you to break it down into its components. So the vertical component would be this one, and the horizontal component would be this one. Again, they'll give you a scale and you just measure with your ruler. So if you were to measure this with this scale, it comes out as 173 kilonewtons, and if you were to measure the length of this with that scale, it comes out as 100 kilonewtons. 9.4, again higher. Draw and use free body force diagrams. So you've got 2 newtons of force getting represented that way, 5 newtons of force getting represented that way, and you'll end up with a resultant of 3 newtons that way. So obviously if it's like tug of war, this 5 newton team has won by how much? By 3 newtons. Again higher. Explain examples of the forces acting on an isolated solid object or a system where several forces lead to a resultant force. So that's what I've just said there. On an object, and the special case of balanced forces when the resultant force is 0. So in other words, if I follow this down here, this time you've got 5 newtons to the left, 5 newtons to the right. That's going to cancel out to give 0 newtons of a resultant. So in other words, the object will remain stationary if it's already stationary, or it'll move at a steady speed. And that ties in quite nicely with Newton's first law, because it is Newton's first law. If you had a resultant force, that's Newton's second law, because that's going to cause acceleration. If you know the size of the force acting on the mass, you'll be able to work out what the acceleration would be. And finally 9.10, back to foundation and higher. Explain ways of reducing unwanted energy transfer through lubrication. In other words, applying oil. So if you apply oil to moving objects like a gearbox or a bike chain, it will reduce friction, which reduces heat and sound that gets wasted to the surroundings. Okay, if it's worth 3 marks, that's what you see. The oil reduces friction, which causes heat and sound to be lost to the surroundings. So best of luck with your exams, and good luck for your future. Work hard, be nice, and bye for now.